dirty stuff now. Okay,
Dirty stuff.
when it comes to energy, I look at it as there are three ways to look at energy. Kind of lenses. There are three ways to look at energy. One through cost, one through consumption, and the other one through pollution or emissions. So we're primarily looking at electricity and natural gas, and I know there are other fuels, propane and other stuff, but we don't always get into. Primarily, we typically get into natural gas and electricity. So electricity, there are several ways it's produced, but primarily coal, oil, and gas, right? Fossil fuel-wise, then there's all the renewable energy and stuff. Fossil fuel-wise, coal is the worst. So if I can play God, I would delete all the coal power plants today. Because that's the worst. The problem is coal is very, very abundant and it's cheap. But it's the dirtiest fuel ever.
Do you think within a small region that there's sources that are radically different? I mean, isn't that almost by state?
No, this is just in general.
Okay.
General using different fuels.
The national average kind of thing?
No, this is throughout the world. And we'll talk about the
But
national
if
averages.
you're
There is
Right.
better coal than others. Some coal is better than others for pollutants.
But coal's
Well,
so cheap that even
that's clean
transporting
coal,
it
and
long distance
that's
is
a
cheaper
whole
Right.
other
than
discussion.
oil.
Coal is very,
Some
very
people
cheap,
say
and
clean coal
there's
is
a
not
lot
cheap.
of coal for the next foreseeable future. There's a lot of coal in the world. So that's why many countries like India and China are just dumping a lot of money in coal.
But if you're getting at we can potentially influence a client to
No.
okay.
That's what I'm going to get at. This is so big that we can't influence.
Right.
What about nuclear and hydroelectric? Are those
Good
not
one.
significant enough?
That's renewable.
Oh,
So they don't have any pollution. Well, we'll talk about the difference in a second. So coal, and then oil and gas are slightly, it depends on the type of just petroleum that you get. And gas is probably the cleanest of the fuel sources, of the fossil fuels. And
But doesn't gas come with a high refinery cost that pollutes?
yes, it does. And that part is still 1/3 of coal. Coal produces 3 times as much emissions as natural gas does.
Well, what about crude oil? Or when you say gas, is that diesel?
No, it's natural gas.
Yeah, okay.
Natural gas. So all the oil products.
So of energy, when electricity is produced with natural gas, that's that part. And then
Right. So this is
energy
where,
of natural gas itself for heating directly is that, okay.
yeah, I'll make that point really quick. So this is trying to create electricity, right? Using one of these forces, you're trying to create electricity. And what happens? How do the plants do that? Combustion, right? Combustion is a problem for all of this pollution. Of the processes, coal is probably the worst. And you can correlate cost directly to pollution to some extent. So the higher the cost is, the more the pollution. It's not always true. It changes a lot by the city, by state.
The lower the cost. Lower the cost. Lower the cost, the higher the pollution.
No. Coal is the cheapest.
Cheapest, so that's a lower cost, the higher pollution.
No, it's actually pretty expensive to use coal too, compared to natural gas.
The argument is we can do it here in America. That's why that's opponents for coal.
No, so why would they
Yeah, why would we use
why would they not
Yeah,
use
outside here.
why would they not use gas? The resources are not as abundant as coal.
In
So,
America. and
in
that's-
America,
that's
but
where
again,
the-
this is globally speaking. Prices can be related to some extent to pollution, but it's not always true based on the local geographical locations.
proponents of coal is largely not because of production costs, but because we have it, as opposed to importing oil
Right.
from
And,
outside.
and I know this is kind of a complicated subject. We'll get to it in the future if we have time. But I just want to compare. If you don't use electricity, and if you want natural gas for heating, natural gas is probably the cleanest of all fossil fuels, which have hydrocarbons in them. And so its pollution rate is very, very limited compared to coal, or compared to the same gas going through electricity production. Likewise, natural gas is really cheap. right? If natural gas is supplied to directly. But if it's used in the combustion process, it is expensive because of all the waste. So finally, renewable, probably the pollution is zero on the renewables, but when it comes to nuclear, is not considered renewable energy. You know why?
It does have waste, nuclear waste.
Yes, that's the biggest problem. And uranium doesn't regenerate. Nuclear fuels don't regenerate. So it's not a renewable energy, but it's qualified as clean energy, but it's not clean. So if I can play God again, I would delete all nuclear plants in the world. Chernobyl incident, do you guys remember that? So many people died because of
That's
the...
not because of the.
Yeah, how far would you reduce the population of the world
No,
if you
Because beyond, that was a
No,
human.
no, I understand, but nuclear is such is a product that has to be handled very, very,
Responsibly.
right, responsibly. Thank you. The problem is the nuclear waste. Right now, they're building a plant in Yucca Mountain. Does anyone know? Yucca Mountain, and if that's passed, starting 2012, they're going to start storing nuclear waste. You know how much U.S. is producing nuclear waste? 2,000 metric tons a year of uranium.
But France, they have a lot more power plants.
So
A higher
imagine.
percentage of their power is by nuclear. Their country is smaller in size than the U.S. I'm not sure how much they're
That would just kind of
produced, right?
Yeah, I'm sidetracking. Sorry. So
Yeah, you're
it's
already off
important.
track.
It's important that to understand the other side of the pollution too,
Sure.
because this is just from a pollution on a climate change standpoint. But there's also waste pollution. Okay. All right. So here's our local to world connection.
No.
Worldwide, of all the energy that's produced, 80% is off of fossil fuels, natural gas, petroleum, crude oil, and coal. In the United States, it's 70%. When it comes to Arizona, it's also 68%, 40 and 28.
Okay.
But we have a huge nuclear power plant, 25%, and then hydro is 6%. Look at how much solar is.
1%.
I mean, we could do better.
Now, is this power
We
plant
can.
consumption? Or
This is power generation.
Does it include residential generation and everything else?
This is the entire generation
Right.
in the state of Arizona.
Right. 'Cause there's
For
a
all
solar
purposes.
that's on a residence that's not part of the APS power.
Right. Yeah, those things don't count
Don't count.
here. Yeah. So the point on this slide is there's a long way to go to change the mixture. So if you go type in your zip code on that website that I'm going to give you, it'll tell you how much of it is nuclear, how much of it is coal, how much of it is gas, and the other. So we'll look at why it is important to our projects in the next slide. So as much solar we can do, we can help this cost because we don't want this dirty fuel, right? Okay.
Where does hydro fit in? Is it renewable, or how do they classify that?
Yeah, they are classifying hydro as renewable because the whole hydrological cycle, the water gets renewed. Okay, so far good. Everyone's pretty sleepy today. Sorry, this is such a dry subject.
12:42.
Oh, that's a number.
It's 12:42.
Just a side note, point we're noticing with some school districts, the more they are able to implement renewables through solar, the more they want to get gas off the campus. Safety.
Right. That's a great point. We'll talk about that right now. So, why is the United States grid, the power grid, considered the dirtiest in the country?
Loss of energy.
Right. This is the problem. Let's say it takes 100 kBTUs or some unit of input, either coal, natural gas, or petroleum, whatever it is. Right. I have to put that into the plant. The plant has a combustion engine or some kind of process that converts that raw materials into energy. So I lose 1/3 right there, right? When it comes out of the plant, it's only 67. And then it has to be transmitted to my house. I lose another 33. So whatever calculation that you did, that 35 kilowatt or 35 kBTU times 3 is how much is needed
Energy.
energy-wise at the plant It's a
Of raw
huge-
material.
Yeah.
of raw material, correct? The potential of raw material. So imagine the impact that we could do if we can get off of this dirty coal, dirty
Whatever power it
grid.
is, yeah.
Right.
Does that change at all if it goes to fiber optics instead of above ground?
The transmission lines, it may. And this is again, this is the national average. This 100 to 33 is about 3, factor of 3 is the national average. And this may not be true for every single zip code. And you can find that if you want. There is an EPA eGrid. You call it eGrid database. You just go type in your power plant, choose your power plant, it will tell you how much its efficiency loss is, if you want to know.
Transmission's probably always the same, but are there certain material, do certain plants produce more efficiently?
Right. That's what the efficiency of the plants comes into play. The older the plant is, the regulations are not that high. Their efficiency are really, really bad. And it depends on what type of process they use to generate electricity. There are several methods. They could use absorption chillers in so many different ways to do that. And I don't know, depending on all that, the efficiency at the plant will change. Let's take this and compare it to natural gas. All you have to do for natural gas is you just got to treat it and pump it. That's it. There's a little bit of loss in treatment, a little bit of loss in transmission. So if I start with 100, the national average is 90. So that's why it's a lot cleaner gas, because I'm not wasting as much as I am for this guy.
You're associating cleaner with efficiency.
Cleaner as in efficiency, right? Because I'm not polluting for the same amount of energy. I'm polluting 3 times here, right?
You're right.
Okay. So let's see how it impacts our designs. Let's go to your home. Let's say you need a new heater for your hot water, right? If you buy a heater that's off of electric, ignore this for now. If you buy an electric heater, right, and it could be 90% efficient. It's a fantastic heater. You can buy a fantastic heater, but it's only 33% efficient at the source, right?
Because you have to take the power to the.
You have to. So if you multiply these two, the net is only 30% efficient. When you compare that same to natural gas boiler, it could be just a standard 80% boiler, but it's 90% efficient because it's directly from the plant, from the source. So the net is 70%.
That's a good one. I like that.
This is the same when it comes to our projects. What do we try to do? What can we do to improve our efficiency? And again, it's very important, us as a project, us as a design team,
Fire generator.
what is our goal?
Source. There it
Is our goal to reduce that? Is our goal to reduce this? Or is our goal to reduce this?
It's a blend of both. And all.
Right, it depends, because for most owners, this would be the goal, right?
Number one.
That's the number one goal, right? But there are owners like the San Diego County where they have to reduce their greenhouse gas emissions by 33%. Regardless of how much they reduce this, they have to do that. So think about how your design strategies will change if the goal changes, right?
Yeah.
Depends on different sources. How do you use the system? Which system do you pick? All these things change. So it's very important to ask the question, what is our goal? So we'll talk about that. I'm probably running too late.
A little bit. It's 12:48.
All right. Maybe we have to cut short our online demo today. So 2030 targets. So why is all this 3 slides important, right?